Very good morning, all my dear lovely students. How are you? How is everybody doing? Good morning, good morning, good morning. Good morning. I welcome you all to this lovely YouTube channel, Shri Chaitanya Educational Institution. Today is our lecture 2. Today is going to be lecture 2 of organic chemistry, where we'll study IUPAC nomenclature. This is one of the most important topic from organic chemistry because once you are, yes, very good morning, Samanvita, Shaheen, Lara, Yashvita, Monica, all subject corner, yes, Prajit, Sudhir, Rohini, Harshita. Very, very good morning, everybody. I hope you have enjoyed yesterday's class and now today also you are, eager to learn IUPAC nomenclature. As we know, among all the chapters of organic chemistry, you have to learn IUPAC nomenclature. It's a very, very important concept. Because many times a question comes, they might not give you the structure of the reactant. They might just give you the name. Something like, what will happen on dehydration of 4-methyl, heptane 2-ol. Something like this they might just ask. So in that case, you must know what is the structure and then only you can start the reaction, right? So to do any reaction, to do all the chapters of organic chemistry, the basic requirement is IUPAC nomenclature. Many of you might think that nomenclature part is difficult. There are too many rules to learn. Let me tell you, in today's class, you will not have any doubt after the class. There are 3 simple rules that you will study today. 3 simple rules. Always follow them step by step. Rule 1, then rule 2, then go to rule 3. Never skip any rule. 3 rules I will give you, simple rules in a basic layman language I will give you. I will not make you write much of English or anything. Simple rules I will give you. Learning those rules, you will never get any name incorrect for NEET level. Okay? So you don't have to do too much of nomenclature as well. Like if I give you a very dangerous molecule where so many benzene rings are there and so many, heterocyclic rings are there, you don't have to do anything like that. We are preparing for a simple NEET or JEE exam. For that, whatever I'll be telling you in this class will be much more than sufficient. Okay, little high level also will go. So this is our today's class, basics of nomenclature. Although I'll try to complete everything today, you will not believe that in one class also you can learn the whole nomenclature. Okay, whatever I'll ask you to write, that all those things you write and practice with me. Okay, and tomorrow also we'll continue with the IUPAC nomenclature. Maybe day after tomorrow also we might continue with the IUPAC nomenclature. So 3 days I will require for you to become perfect in this particular topic. Whatever previous knowledge you have, that's a good thing. Whenever you think you get a doubt, please ask me in the chat box. I'll reply to you. All right. Okay. Everybody, we can start writing from here. Whenever you look at any IUPAC name, the name generally consists 3 major parts. All of you know about this. Prefix, word root, suffix. Prefix, word root, suffix. Just like for us, if I want to write my name, I'll write my name as Mr. Anirudh Mehta. In the same way, most of you also write your names like this only. You will be writing it as Dr. Yella Sudhakar. Doctor will be your prefix. Yella will be your center name or word root. And whatever comes at the end, Sudhakar, that will be your surname. Surname means suffix. Now, many of you have little complicated names also where you might include 2 surnames. Okay, you might include 2 surnames. So, in the same way, when you look at the Aadhaar card name of any organic compound, these are all Aadhaar card names. You have to write them as it is. You cannot do any mistake. Okay, so in that case, there are actually total 5 parts in the name. Maybe all 5 may be present. Okay. In some compounds, maybe only 2 of them are present. So we'll write it down. Word root in the middle, suffix on the right side of the word root, prefix on the left side. Suffix is of 2 types, primary, secondary. Prefix is also of 2 types, primary and secondary. Whatever attaches near to word root is always primary. Okay. So word root, near to word root, primary suffix. All of you can write it down quickly. Start writing primary suffix. And whatever comes later is secondary. So secondary suffix will come at the end. Word root, I'll just write as WR, word root. Word root is followed by primary suffix. Primary suffix is followed by secondary suffix. Just before word root will be the primary because it is attached to word root, primary prefix. But a primary prefix is a very rare term. Okay, in 90% of the compounds, this is absent only. I'll show you how. And then whatever comes in the beginning of the name is secondary prefix. I know all of you are well aware of what is word root, what is suffix. Just to tell you quickly, please remember the middle three things only talk about parent chain nature. Middle 3 things only talk about nature of parent chain. They only talk about parent chain. Okay, parent carbon chain. So we will select a parent carbon chain. In parent carbon chain, you should know how many carbons are there in the parent carbon chain. That word root will tell us. So word root tells us about number of carbons in parent chain. Okay, number of carbons in the parent chain. And all of you know that the word roots are meth for 1, eth for 2, prop for 3, but for 4. No need to write. All of you know this. No need to write. Okay, just write this part what I am writing. Okay, no need to write that meth, eth, prop. All of you know that. I'll give you the table also. If you want, you can write it later, but not right. Now, once you know how many carbons are there in the parent chain, you want to know whether parent chain is open or close. Whether it is an open chain or it is a cyclic chain. That primary prefix will tell you. So primary prefix tells you about cyclic / open nature of parent chain. Okay, if parent chain is open, then there is no primary prefix. Okay, all of this we will write later. Right now, just make this flowchart kind of thing. Okay, so primary prefix is not present if there is an open chain. Yes, Lara, that is correct. So like butane, methane, so meth, and there is nothing behind it. So primary prefix is very rare. Only cyclo you will be using, cyclo. There are others also, bicyclo, spiro, cyclo, bicyclo, spiro, 3 are there. But for our syllabus, only cyclo is sufficient. Cyclohexane, and so. Then, after knowing this, we want to know whether our parent chain is saturated or unsaturated. Whether our parent chain has any pi bonds or no pi bonds. If parent chain is saturated, our primary suffix will tell us. Beta, these 2 things are a must in a compound. Every name must have a word root and a suffix. Like methane, ethene, butene. So these 2 are the must. Others are maybe present, maybe not present. Okay. So what is primary suffix going to tell you? It will tell you the saturated / unsaturated nature of parent chain. Only parent chain. Okay, nothing about the side chains. So we have only learnt about the parent chain till now. Okay, I hope it is clear. Now, after our parent chain is done, two things are remaining. One is main functional group. A main functional group is that person who gets a surname. All of you have heard of pentanol, pentanol, pentaneoic acid, pentanone. So this on, oic acid, whatever comes at the end is the most important person of the molecule. Most VIP of the molecule is going to get the surname. Surname is most important person for us. So what does secondary suffix tell you? It tells you about the main functional group which tops the priority table. Please write it down. This tells about the main functional group which tops the priority table. Okay, so secondary suffix, I'll give you a priority table where you will see up to rank 13 ranks will be there. So whenever in your molecule there are 2-3 different functional groups, you will look at their ranks. Whoever will be ranked on the top will get a surname. One simple example, let me show you. All of you can see one simple example here. All of you, please try to name this. First I will name, second one you try to name. Okay, all of you can see here this particular compound. Okay, so when you look at this compound, its name is going to be something like this. I'm not writing the full numbering and everything. That rules I will tell you. Can you name it, everybody? Can you try to name it? How many people can name it? Quickly write the name of this compound in the chat box. I am waiting for you so that I know what is your current level. Accordingly, I'll go further with a slower speed or with a faster speed. Okay, what is this? What is this compound? Pent-2-enol. Samanvita says pent-2-enol. Pent-2-en-2-ol, that is better. Gangam Rajendra says pent-2-en-2-ol. Very good, very good. All of you are doing great. That means most of you, I am waiting for others also. Pent-2-en-2-ol, Shaheen, Prajit, 2-en-2-ol. Yes, Shavana Shriya, that's correct. Shaheen, that's correct. Satyanarayana also is saying correct. So all of you are saying it correct. Very good. That means I am dealing with good bunch of students. I'll teach you much more complicated things afterwards. Okay, I'll start with the basics, don't worry. So what you have done here is you have taken the parent chain. So I can see here 1, 2, 3, 4, 5. 5 carbons are there. And it's an open chain. So I'll start thinking from the scratch that 3 parts are there. And then there are total 5 carbons. It's an open chain. So primary prefix absent. Word root is pent. Yes. Now, since there is the unsaturation, we'll say ene. So pent plus ene. Okay. Your suffixes and prefixes are also going to tell you the location. Of functional groups and unsaturation. So since the unsaturation is coming at second number, we'll see the numbering later. I hope all of you remember the numbering. Numbering will be done in such a way that alcohol should get the lowest number. So I'll number like this: 1, 2, 3, 4, 5. 2 pe ene. So there is pent-2-ene. And at number 2 only you're getting ol. So 2-ol. Then you join this name together. Whenever you are joining suffixes, you already know from your previous classes that if 2 vowels are coming together, E plus O, then the E of the ene will be omitted. Yes. This E will be omitted. So the name will be pent. Just remember these small rules I am telling you. I'll give you a rule book for this as well, but it's not required. It's very simple. Always start the name with a block letter, or we can say always start with a What do you say? Bigger letter. I forgot the caps lock. Always start with the caps lock. What do you call it? What is that big letter called? Always start with the simple English words also we forget in between. Pent, to, in, to, ol. In between the name there should not be any spaces. Okay, capital letter, sorry, capital. Now I remembered. So start with the capital letter. So pent, to, in, to, ol, and always. Yes, thank you. No, I remembered before you told me. Yes. Uppercase. Caps lock, uppercase, capital, yes. Big letter. Our first language is not English, no. So we are used to talk in, you are used to Telugu, I am used to Hindi. So we have to convert first. We are all sailing on the same boat. Okay. We are all sailing on the same boat. So that's we should be proud of our own language. Okay. So if you should be proud of Telugu. You should talk to friends in Telugu. Anyways, you'll learn English because NEET has to be written in English. So we don't have any option. Okay. Pent, to, in, to, ol. Always write the first alphabet as capital. And do not leave any space in between. And whenever you are, separating two numbers, put a comma in between. 2, 2, 3, 3, 2, 4. And whenever you are differentiating between a number and an alphabet, put a hyphen in between like this. So pent hyphen to hyphen in hyphen to hyphen ol. Okay. Now, once you know about your main functional group, what is remaining? Whatever is remaining is going to come into the beginning of the name. Secondary prefix, least important people for us, we will put in the beginning. Least important people for us, we'll put in the beginning. Secondary prefix. Secondary prefix, which is going to tell you about any other functional group which is present, okay, which could not top the priority table. For example, if there was a Cl here, Cl, then Cl has no surname. It just has a prefix, chloro. So now the name will become 4-chloro. So in the beginning we will put the chloro, 4-chloro. Then 4-chloropent. So we will not be leaving any space in between. C will be capital now, 4-chloropent, 2 in 2, like that. Okay. So this is how we will mention if there was a Cl attached somewhere in the fourth number. Like this. Okay. Yes. So now what is going to be secondary prefix? It will tell you about location and presence of side substituents, which could be other functional groups who could not top the priority table, or which could be alkyl chains, beta. Alkyl chains. All the alkyl chains, you'll be able to name them very soon. Okay. So let's write about the secondary prefix. It talks about any secondary functional groups, or alkyl substituents. Okay, beta. As we know, all the carbons in a compound cannot be taken as a parent chain. Parent chain so will have to start from here and has to end here. One beginning, one end will be there for the parent chain. Any carbon in between will become a alkyl substituent. So all those names will be coming as prefix. Okay, so you can quickly write it down. Then we'll start moving to the main portion of this chapter, which is actually writing the names. Everybody clear up to here? Yes or no? Quickly. So within first 20 minutes, we know that what all things name will contain. Yes. Now what I want you to do is, I'll show you some example of names. I want you to underline where is word root, where is primary prefix, where is secondary prefix, where is primary suffix, where is secondary suffix. Okay, so let's do that. Okay, so I have told you these things. You can just see here once. No need to write anything. You have written everything there. Okay, primary prefix represents if it is non-cyclic, no primary prefix. Cyclic, cyclo, bicyclic, tricyclic, spiro are not there in the syllabus. Okay, not in the syllabus. One example, if you want, you can just mention them. Okay, one example you can mention them. Whenever beta there are two rings, whenever there are two rings which are attached by two carbons, we call them as bicyclo compounds. Just the classification you learn. No need to know how to do the naming. It's not there in the syllabus. So whenever two rings are joined by two carbon, bicyclo. Whenever two rings are joined by one carbon, something like this, spiro. And whenever there is a single ring, that is cyclo. Cyclo, bicyclo, spiro. Three types of, sir, spiro means spiro, beta, there are some compounds called as spiranes, which are two rings joined by one carbon. That is called as spiro. These compounds are called as spiranes, just like alkanes we have, no? Okay. Yes, that is correct. Bicyclodecane is not the full name Jyotisai, but you are saying almost correct. Just the numbers are missing. But these are out of syllabus. Whatever is out of syllabus, just leave it. Okay. When it comes to isomerism part, then you will be requiring to draw them. You might require to draw them. Okay, you don't have to know their names. But in the isomerism part, I'll give you some complicated questions where spiro and bicyclo also will be made. Okay. Next, let's move to the next one. These are all things all of you know. Myth, ith, prop, but, pent, hex, hept. Don't say sept. Don't say sept. Hept. 7 is hept. Oct, non, dec, undeck, dodeck, trideck, sufficient up to 13. Rest are there. Icosane, C20H42. Icosane. So icos, 20. Triacont, triacontane, 30 carbon. Dinesh has a good doubt. Dinesh is asking, sir, bicyclo. Beta, Dinesh, these are bicyclo compound. This is not bicyclo. They become aromatic compound now. Aromatic compound naming is separate from bicyclo. This was bicyclo. Okay. Whenever benzene rings come into picture, no, they become fused benzenoids compound. Their naming we can do. Naphthalene, anthracene, pyrene, and so on. Those you can do. Okay. This is bicyclo. Whenever there are circles inside it, circles or alternate pi bonds like this, now they are not bicyclo compound, they are fused benzenoid compound. Different definitions. Okay. So this is there for the NEET. This is not there. Okay. So these are the ones. Next one. Primary suffix an, in, ein, diene, diine, enine. Okay. So these are the things. Now, I am giving you few names. You kindly underline what are the parts available in this name. Okay. One example, let me tell you. If I look at, everybody see here, as soon as you see a name, first directly try to attack on the word root. Now, where is the word root? Word root is that ith, myth, but, which is directly attached to an, in, ein. Okay. For fourth example, I am telling you. There is a prop here, but this prop is not the word root because prop is attached by il. Il is not a primary suffix, we know. So, where is the word root? Prop or hept? Hept is the word root here. Hepta. Hepta. This is the word root here. You might say, sir, it was the hept. Now comes another point that you should remember. Okay, no need to write these points. Just keep remembering. You will be able to learn all of them. See, whenever your primary suffix starts with a non-vowel, with a consonant like di, tri, tetra, then if I write my word root normally, it will not sound good. It will not sound good. For example, if I say heptadiene, butadiene, propdiene, now the name is not continuous. Okay, what is the use of vowels in English? The use of vowels is to make a name continuous. So whenever you are putting a vowel somewhere, no, it becomes a very continuous name. Like heptene is good because E is a vowel in between. Heptene, butene, propene, good. But when I say butadiene, I have to stop myself in between. Butadiene. Instead, I'll say butadiene, heptadiene, hexatriene, pentadiene. So whenever your primary suffix starts with a di, tri, tetra, to make the name sound beautiful, just put a in between. So that name becomes continuous. Cyclooctatetraene, like that. Cyclooctatetraene, octa. Okay, is it clear to you? Yes or no? Please remember it now. So never say heptadiene. It's a it's a crime to say heptadiene. Heptadiene, butadiene. Yes. Okay. Is it clear? Yes or no? This is the word root. Whatever comes after the word root is going to be primary suffix. Diene. So 2,4 diene, the whole thing is primary suffix. Primary suffix. Now, just before word root, do you see any cyclo? No, sir. So it's an open chain compound. It's a open chain compound. So there is no primary prefix. Now, whatever is remaining has to be secondary prefix. This whole thing is secondary prefix. So in this compound, now we can draw the compound also. As soon as you look at the name written, you can draw the compound as well. Okay, let's draw the compound. They say word root is hepta. So first I am concerned with my parent chain, 7 carbon. 1, 2, 3, 4, 5, 6, 7. This is the parent chain. Hept. Word root. Hept. Number it from anywhere you want. Let's number from here. 1, 2, 3, 4, 5, 6, 7. 7 hept. 2,4 diene. On second number there is a alkene. On fourth number there is a alkene. 2,4 diene. Yes. And then secondary prefix is 4 pe cyclopropyl. At fourth number, I have a propyl. Propyl means 3 carbon, but it's a cyclic alkyl. So I'll make a cycle, a triangle like this. This is the compound. Primary prefix absent. Yes, secondary prefix present. Correct, Chandrashri. Correct, Gangam, sorry. Is this clear to everybody? Yes or no? Now, can you all draw the other compounds? Can you all draw the other compounds? And quickly mark what is primary, secondary, word root, primary, secondary. If it is clear, quickly mention clear and like the video. Only 9 likes are there. There are 56 students watching. I want 56 likes to be there. Okay, Samvitha has told the first one. Secondary prefix, word root, primary suffix. Word root and primary suffix will always be there, I told you. Quickly like the video. 60 people, 60 likes, then we'll continue. Good, Lara. Lara saying first mein hept word root. Okay. 4-methyl secondary prefix. Okay. 2-ene primary suffix. Good. Very good. Very, very good. Clap for yourself. And quickly draw their structures also, everybody. So in this case, I'll first attack on the word root, which is hept word root. 2-ene primary suffix, nothing secondary suffix present, no secondary suffix present. Then there is no cyclo, there is no bicyclo. So there is just a secondary prefix. Secondary prefix. Draw it. Heptene. 1, 2, 3, 4, 5, 6, 7. Numbering from here. 1, 2. 2 pe ene. 1, 2, 3, 4. 4 pe methyl. 1 carbon outside like this. Yes, second one. Now, bute is the word root. Bute. Ane, butane. This is the primary suffix. Butane. One on, secondary suffix. You can all see here, butane ends with a vowel. On starts with a vowel. Whenever there are two vowels together, name does not go well. Only one vowel should be there. When I say butane on, not good. Butane on. Only single vowel always makes the word continuous. Butane on. Cyclo is there. So this is primary prefix. And this is secondary prefix. So all five parts are present. Very rare names are like this. Very rare. Okay. Generally, compounds are not like this. Okay. So let's draw this. Let's draw this. Just do one thing, everybody. Instead of bute, just call it as hex. Otherwise, this is not a feasible compound. 3-hydroxycyclohexane 1-on. Okay, this one. So, what is the structure going to be? Cyclohex means I have to make a 6-carbon cycle. Cyclohex. Cyclohex. Okay. Cyclohex. Now, numbering you can start from anywhere. I am writing the numbers in the middle of the chain. 1, 2, 3, 4, 5, 6. At number 1, there is a ketone. So, on. This gets our surname. So, because when you look at the functional group priority table, you know ketone is more important than alcohol. At number 3, we get hydroxy. Put a OH here. Put a OH here. Gangam is asking, sir, why not feasible with butane? Beta, the numbering was wrong. There can never be a 3-hydroxycyclobutanone because then it would look like this. Okay, and this is not 3. 1, 2, 3. Okay, 3. That was also possible. That was also possible. Possible only. I wrote it correct only. This is also possible. Okay. I thought here number is written wrong. The number is correct also. 3-hydroxy is also possible. This also you can draw. That also you can draw. Both are correct. So this is hexane 1-on. This is butane 1. Both are fine. Feasible. All feasible. Okay. So this is butane on 3-hydroxybutane on 3-hydroxycyclohexane. Okay. Next one. 4-oxo-butanoic acid. Can you tell me what functional groups are present in the third one? Functional groups present in the third one. Which all functional groups are present? Can you tell me? Options are, first one, ketone plus carboxylic acid. Option 2, aldehyde plus carboxylic acid. Option 3, ketone plus alcohol. Option 4, only carboxylic acid. Can you tell me? Okay, alcohol and carboxylic acid, someone is saying, shall I put that option? Alcohol, I didn't put that option. See from the option and tell. Trap question, everybody. Trap question. Yes, all of you are giving wrong answer. All of you are giving wrong answer. Did you draw it and check? Always draw and check. Don't directly say anything. Always draw and then check. Answer is aldehyde and carboxylic acid. Did you draw it, everybody? First draw it, no beta. It's a butanoic acid. 4 carbons are there. On 4th number, I have put a oxo. Can a ketone come on corner? Tell me. Can you ever get a ketone on the corner? Ketone can never come on corner, no beta. Aldehyde will come on corner. So ketone and aldehyde, both of them have same prefix, oxo. Okay, both of them have same prefix, oxo. You have to draw and check whether it is coming in the middle or is it coming on the corner. Whenever oxo is coming on the corner, it will be aldehyde. You see here. You see here. I'll draw it. Okay, I'll draw it. You see here. Okay, let's draw. Butaneoic acid, 4 carbon. Okay, I'm just drawing it normally. 1 carbon, 2 carbon, 3 carbon, 4 carbon. Oic acid, C double bond O, OH. Numbering must start from the oic acid side. 1, 2, 3, 4. On 4, there is a oxo. Oxo just means double bond. Oxo just means double bond. So, at number 4, we have oxo, which is this. Okay. Yes. So, don't do the mistake. Now, it's not a ketone, it's an aldehyde. There should be a H to complete the valencies of carbon. So, this will be CH2, CH2, CHO. COOH, CH2, CH2, CHO. Yes. So, don't do this mistake. So, 4-oxo is a secondary prefix, but is a word root, ane is a primary suffix, oic acid is a secondary suffix. Nobody from Maharashtra, please study here. Telange, Shri Krishna. Study. Okay. Now, we'll start with how do we reach to the names. Quickly write down, everybody. Rules of IUPAC nomenclature. There are 3 basic rules we need to follow, but follow them one by one. Write it as a promise. I will follow these rules one by one. If you skip any rule, name will go wrong. 3 rules are very simple. Rule number 1. Rule number 1 is parent chain selection rule. Parent chain selection rule. Okay, listen to the rule carefully. Some of you might be doing mistake somewhere. In the simple questions, mostly you will not do mistake, but when the question become little complex, you will try to skip some rules. Don't skip them. Parent chain selection rule. First of all, do not call it as longest chain rule. Otherwise, you have this bad or wrong notion in your mind that whenever I have to select the parent chain, I have to select the parent chain, the longest one. It is not correct. No. Not longest chain. Please see here. Please see here. So, you'll have a wrong notion in mind. Don't keep that wrong notion in mind. Can you tell me here how many carbons are coming in the parent chain? If you correctly select the parent chain here, can you tell me how many carbons are coming in the parent chain? Can you tell me the number of carbons? I am asking. If you have an idea of how to select the parent chain, then can you tell me how many carbons will come in the parent chain of this compound? Think. I am asking you a very, very good question where most of you might do mistake. How many carbons will come in the parent chain? In this compound, how many carbons will be there in the parent chain? Prajit says 11, Varuna says 9, Chandana says 5, Samanvita says 11. That means now there is some problem, no? That means the rule is not very clear to you. Harshita says 9, Prajit says 11, Gangam says 4. Only Gangam and Jyoti Alagi, only 2 people have said the correct answer. And A also. What is your full name? A, just write your name as well. Monica has given the correct answer. Yes, Sudhakar. Yes. So, first of all, admit this, that I don't know the rules of nomenclature. Start from fresh. Start from fresh. You don't know the rules properly. Okay? And there is nothing to worry about because anyways, you have one whole year. Do everything with the base. So, simple names you are able to do, but you are doing mistake in such things. Yes, 4 only are there. So, many of you might be thinking, sir, longest chain rule. Let me select the longest chain like this. I'll start from carboxylic acid because this is carboxylic acid. I know that, sir, we have to start from the most important functional group, carboxylic acid. Then long chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. When you study the rule will say parent functional group, main functional group carbon must be included. This carbon must be there. Then unsaturation must be there. That the rule will say when we will study the rule. No lowest sum rule, beta. What I will tell you, please do that. There is no lowest sum rule. GS bros, okay? Some books might have mentioned it. It's a wrong rule. There is nothing called as lowest sum rule. Before 1994 or 93 it was there, but now there is no lowest sum rule, okay? After taking the main functional group's carbon, rule says that you must take your ene. I told you, na beta, most important person of the whole name is this person. Simple rule is there. Whenever you want to take the parent chain, this person must be taken. The one who gets the surname must be taken. After taking this person, you must take this person. Means ene. You must take ene and ine in the parent chain. Without that, you can't choose the parent chain. After you have taken them, you must satisfy this person, word root, means number of carbon. Then you will try to increase the carbon chain after taking the alkene. Okay, so who is most important person for the compound? It is main functional group carbon. After taking main functional group carbon, who will you take? You will take your unsaturations because he is also a surname for us. So surname people are most important. Okay, most important is this. Second most important is this. Third most important is this, number of carbons. Third most important is number of carbons. Then we try to maximize the carbon. If you have maximized the carbon, then you try to maximize these things, means substituents. Try to maximize substituents. Okay. So we'll write those rules. I have not written the rules yet. So after taking these 2 carbons says we must be there in the parent chain. You cannot have the parent chain without 2 of us. So we say, okay, you 3 are important for me. Let me take you 3. I will not go there. This is the parent chain. We can leave all these things. We can leave CN outside. We can leave OH outside. There is only one king of the jungle. No 2 kings. There is only one king of the jungle. I am explaining it again. Angel, I am explaining it again. Beta, I have not written the rule yet. I will write the rule. First rule says, while selecting the parent chain, listen carefully. While selecting the parent chain, first point, carbon carrying the main functional group, which tops the priority table, must be included. This carbon says, I am the carbon of COOH. I must be included. You cannot have a chain without me. This is most important person for us. Okay, this is a 5-star person for us. 5-star means very, very important. Most important. After you have taken him, then unsaturation say we also have a surname. No, why are you neglecting us? We also must be taken. 4-star person for us. This is the 4-star person. This person also, this person also, because I can't see any other pi bonds. So we'll say, okay, I will include U3. Then comes maximum chains, maximum carbon. So taking these 3, I have to take maximum carbon. There is only this way, because if there were more carbons here, I would have gone ahead. But there are no more carbons, so I will stop here. So I'll say, okay, the parent chain starts from here. Parent chain starts from here and ends here. Is it clear to you, Angel? So before satisfying your suffixes, don't try to maximize carbons. Carbons are not important. Functional group is important. Then unsaturation is important. If these things are not there, then carbons are important. Yes or no? Shall we write the rule now. Let's write the rule now. Yes. Rule number 1 is parent chain selection rule. We'll write it after 2 minutes. Rule number 2. After selecting the parent chain, you must number the parent chain. You must number the parent chain. Numbering the parent chain. The rule will be called as lowest locant rule. Never call it lowest sum rule. There is nothing called as lowest sum rule. Lowest locant rule is the name. Lowest locant rule, which we will use for numbering of parent chain. Same thing. If you know the rule 1, you know the rule 2. Who is most important person? Carbon of main functional group. He must be getting the lowest address. Locant means address. So, anyways, once you have chosen the parent chain, it will have two ends. This end and this end. So, either numbering can start from here 1, 2, 3, 4, 5, 6 or from here 1, 2, 3, 4, 5, 6. Two ways only are there. Way should be chosen in such way that most important person, secondary suffix person, must get the lowest number. If he is satisfied, unsaturation should get the lowest number. First, this person should get the lowest number. If that is satisfied, this person should get the lowest number, alkene or alkyne. If this is satisfied, then substituent should get the lowest number. In case your main functional group got the lowest number, alkene also got the lowest number, but still you are not able to decide where to number from, then substituent should get the lowest number. Substituent. Okay, we'll see that. I'll write the rules. I have not written the rules yet. One example I'll keep giving you. I'll write the rules. Okay, for this one, obviously numbering can start from here or here. By following the rule, I will say carboxylic acid carbon must get the lowest number. 1, 2, 3, 4. Okay. Let's see second example, everybody. I want you to number it. Okay. Please see here. Tell me, what are the set of locants here? I am asking this question. I am asking this question to you. What are the set of locants? If you number it correctly, what all numbers will come in the name? Okay, just choose the parent chain yourself first. Choose the parent chain yourself first and then number it yourself. I'll give you time. There is no problem. I'll give you a lot of time. Take it like this. And if you want, you can tell me the name of this compound as well, because most of you are okay with naming, I know. Select the parent chain quickly. Beta, locant does not mean the locant of unsaturation only. Locant will be there for the substituent also. Okay, no problem. I am not asking, I am not judging you right now. I have not taught you this. I will teach you afterwards. No, just after this, one by one, we'll study the rules. Right now, let's select the parent chain. Main functional group, I am absent. Main functional group, absent. Okay, unsaturation, these two carbons say we are most important for you. These two carbons say we are also most important for you. So by taking these 4 carbons, I have to select a chain. By taking these 4 carbons, I have to select a chain. That means I have to go like this, 1, 2, 3, 4, 5, and then maximize the number of carbon. Keep going till you reach to an end. 1, 2, 3, 4, 5, 6, 7. This is the parent chain. This is the parent chain. Okay, now numbering. Numbering will be done in such a way that main function will get the lowest number, main function group. So absent. Then unsaturation should get the lowest number. So whether I should number it from this side, 1, 2, 3, on third number I am getting unsaturation. Here on number 1 only I am getting. So I'll number from here. 1, 2, 3, 4, 5, 6, 7. Yes, 3-propyl hepta 1,4-diene. Very good. Correct. The name you have done correctly only. So this is the one. So locants are at number 1 there is something, at number 3 there is something, and at number 4 there is something. So 134 are the locants. That means when you write the name, you can see your friends have written the name. They have written the correct name. Gayatri has written correct. Sudhakar has written correct. Anu has written correct. These 3 numbers are coming in the name. 134. 3-propyl hepta 1,4-diene. That's correct. This will be second rule. See everybody, I told you 2 rules and you are able to answer the name. That means, is rule 3 required or not required? Tell me. Do we require rule 3 or do we not require rule 3? Should we talk about another rule or should we stop here? What should we do? Why do you need a third rule? Do we need a third rule, yes or no? Because by looking at first 2 rules, I am able to answer the name. I am able to tell the name. I selected the parent chain. I saw the lowest locant rule and I named it. I named it 3-propyl hepta 1,4-diene. In some cases required, yes. Whenever your rule 2 is not able to give you a proper answer, whenever rule 2 fails, then go to rule 3. When rule 2 fails, then go to rule 3. What is the rule? Rule is dictionary rule. Open the dictionary and this will tell you the answer. Open the dictionary and this will tell you the answer. We'll call it as prefix rule. Prefix rule. Bracket, note point. Only use when rule 2 fails. Only use when rule 2 fails. Yes. When will rule 2 fail? You see here. Rule 2 will fail whenever from both sides same locants will come. Whenever from both sides same locants will come, then your rule 2 will fail. For example, if I have this compound, let's say I have this compound. Okay, everybody, I have this compound. First of all, I am thinking who is the main functional group. Bromo, chloro, fluoro, none of them is main functional group. They don't have a surname only. Okay, I'll show you the functional group table tomorrow. So there are total 13 functional group only who can get a surname. Not everybody can have a surname. Halogens do not have a surname. Nitro does not have a surname. So they are not important for us. You are not important, you are not important, you are not important. None of you are important. Then unsaturation. Let's keep one unsaturation also. Okay. So these 2 carbons says we must be there in the parent chain. Okay, no problem. We'll take you in the parent chain. So taking two of us, select the longest chain. So I'll start from here and there. That is the longest chain. So this is the parent chain. 1, 2, 3, 4, 5, 6. Hexene is the parent chain. Hexene. Now I start to number. See beta, if I number from here 1, 2, 3, 4, 5, 6. If I number from left side to right side, What are the locants I am getting? Beta, the locants I am getting are 2, 2, 2 substituents on second number, then 3, 2, 2, 3, 5, 5, 2, 2, 3, 5, 5. Locants are 2, 2, 3, 5, 5. 223, 55 are the locants. 223, 55. Okay, if I number from the other side, 1, 2, 3, 4, 5, 6. If I number in the pink way, then I'm getting 2, 2 because 2 substituents are there, no? So 22, and there is third number where there is an in, and then 55 again. So I'm getting same thing, 2, 2, 3, 5, 5. So the thing is, from both sides you're getting same locants. That means if I study the rules up to here only, I will fail. I don't know what to answer. Should I answer it as 2 chloro, 2 methyl, 5 fluoro, 5 bromo? Should I answer it like this? Or should I answer it like this? 2 bromo, 2 fluoro, 5 chloro, 5 methyl. In that case, you will require your rule number 3. Rule number 3 will say open the dictionary. Open the dictionary. Whichever substituent is coming first in dictionary, that should get the lowest number. Here I have bromo starting with a B, fluoro starting with a F, chloro starting with a C, methyl starting with a M. M, C, F, B. So when you open the dictionary, bromo will come first, no? Bromo starts with a B. So we should number in such a way that alphabetically prior substituent must get the lowest locant. So B says, I am the king of the jungle today. I should get the lowest number. So this numbering is incorrect. This numbering is incorrect. This is incorrect. This is correct. Yes. 2 bromo, then chloro, and 5 chloro. Naming will do later. Right now, just rules I am telling you. Everybody, is it clear? Is it clear what I have just told you? We have not written the rules. We will write the rules now. We will write the rules now. Beta, we need to select just the first person. Who comes second, third, fourth is not important for us. You open the booklet, you open the dictionary. Whoever comes first, once you have the winner, start from the winner side, that's all. Start from the winner side. Yes, Angel, whichever question comes from nomenclature, you'll be able to do then after listening to this class. So 3 rules are there. We will follow the 3 rules one by one and then we'll start naming them. Quickly tell me if it is crystal clear. Write a crystal clear in the chat box and like the video. Then we will start with our next slide. Quickly. Like the video. Write crystal clear if everything is clear so that I can move on further to give you good amount of questions. Okay, thank you. Good. That's good. Okay, so within 2 minutes, we'll write the rules quickly and then we are going to practice some questions. Okay, quickly write the rules. Rule number 1, parent chain selection. Everybody write it. Parent chain must be selected in such a way that number 1, carbon bearing main functional group must be included. This is the first thing. After doing this, you will go to maximum number of unsaturations. Must be included. Okay. So this is the rank 1, this is rank 2. After doing this, you will go for the next step. Maximum number of carbons must be taken in parent chain. After you have maximized the number of carbons, still if you are not able to choose the parent chain, then try to maximize the substituents beta. Then last step, maximum number of substituents must be present. Okay, don't skip any step. Do not skip any step. Quickly write it down. I'll show you 2 examples. I'll show you 2 examples. All of you can see here. Okay, all of you can see here. All of you can see here. I'll quickly choose the parent chain among these and I'll show you how to do it yourself also next time. So I'll start the rule saying that main functional group bearing carbon. Carboxylic acid is the main. This carbon must be taken. This carbon say I am most important carbon. Then unsaturation means these 2 carbon. So taking these 3 people, I can go straight from here to here or I can go down beta. If I go straight, how many carbons I am getting? 1, 2, 3, 4, 5, 6. 6 carbons I am getting. But if I go down, 1, 2, 3, 4, 5, 6. Now also I am getting 6. Alright, both sides we are getting 6. If I am going straight, I am getting 6 carbons. If I am going down, I am also getting 6 carbons. But if I go straight, if you see carefully everybody, if I go straight, then the number of substituent is only 1 substituent, which is here. Single substituent is there. This big substituent, only one, but only 1 substituent. Coming on number 1, 2, 3, 4. Fourth number pe 1 substituent is there. So if I do the blue way, I get 1 substituent. But if I do the green way, then the number of substituents are 1 ethyl, 1 of this methyl, 1 of this methyl. I am getting 3 substituents. 1 substituent, 2 substituent, 3 substituent. So this green way we should do. Green way. This is correct. That was incorrect. Is it clear everybody? Yes or no? Why the green way is correct here? Is it clear to everyone? Is it clear to everyone or not? Why I have chosen the green, not the blue? Yes or no? 4-ethyl 5,5-dimethyl hex 2-ene oic acid. Very good. Correct. Chandana has given correct answer. Naming is fine. You will do the naming after some time. Is the parent chain selection clear to everybody? Parent chain selection clear to everybody? Clear. Okay. Next one. Ketone says I have a surname, own. I must be there. Alkene say we must be there. Okay, we'll take you. So this cycle is the parent chain. This cycle is the parent chain without any doubt. Next one. No functional group, no unsaturation. Directly try to maximize carbons. Okay, let us see. 1, 2, 3, 4, 5, 6, 7. 7 I am getting. 1, 2, 3, 4, 5, 6, 7. 7 I am getting. 1, 2, 3, 4, 5, 6, 7. Array, 7 I am getting. Red is also 7. White is also 7. Pink or white, I don't know what that color is. Green is also 7. Tell me, should I take green? Should I take red? Or should I take pink? Again, I am showing you. Green is this. Green. Should I take green? Should I take pink? Or should I take red? Tell me. Just answer it as green, pink, red. Green, pink, red. You can draw and check. Red. Very good. Red is correct. Red has more substituents. Red has more substituents. Let me check. When you take green, there are 3 substituents, beta. Green has 3 substituents. Methyl, this isopropyl and isopropyl. Total 3 are there. What is isopropyl? What is secondary butyl? I'll tell you all. Right now, not required. But 3 substituents are there. If I leave the green but I take the pink one, in the pink one, substituents are 1, 2, 3. Again, 4 substituents are there. 4 substituents are there, beta. 1, 2, 3, 4. 4 substituents. So, pink better than green. Pink better than green. No, Angela. Angel. Angel, no. Beta, Angel, when you take the green one, don't see the substituent is very bulky and branchy. We don't need that. How many branches are attached to the green line? 1 branch, 2 branch, 3 branch. Only 3 branches are attached. Okay. Green has 3 substituent. Green has 3 substituent. I'll just mention it here. Green has 3 substituents. When I look at pink, pink has 4 branches. You see here, branch number 1, branch number 2, branch number 3, branch number 4. 4 branches. Pink has 4 branches. And when I go for red, see the branches, everybody. Red also has 4 branches. 1, 2, 3, 4. Red also has how many branches? 4. Correct. Now this question becomes a difficult one. So you are not able to select the parent chain only. Although in NEET such question will not be asked. Okay. Although in NEET such question will not be asked. But in case I am giving you the question, I will tell you what is the way to do here. In such a thing where branches are also not able to tell, then go to second rule, locant rule. No, pink also cannot be the answer. Answer will be one only. Either red way will be correct or pink way will be correct. But answer will be only one. What will be the answer? According to locant rule. So by whichever way, when you start writing the numbering, whichever gives you locant earlier will be chosen. Again I am showing, just see here. So if I take the red one, my locants will come 2, 3, 4, 5. 2, 3, 4, 5 locants will come. 2, 3, 4, 5. 2 methyl, 3 isopropyl, 4 ethyl, and 5 like this. 2, 3, 4, 5. If I take the pink one, okay, if I take the pink one, locants are 2, 3, 4, 5. 2, 3, 4, 5. Actually, pink and red both are same only. Pink and red both are same only. There is no difference in the two. Okay, here also 1, 2, 1 pe methyl, 2 pe ethyl. Here also 1 pe methyl, 2 pe. Both are same only, beta. There is no difference. There is no difference. Both have same carbon. Both are identical. Just that one is written like this, one is written like this. Both are same. There is no difference in both. Okay. You write the name from both, the name is coming also same. So both are same. Anything you can choose. If I take from the pink one, you can see here 1 methyl, 2 ethyl, 3 pe isopropyl, 4 pe methyl. Okay. These numbers are coming. And on the red also same, identical. There is no difference. 1 pe methyl, 2 pe ethyl, 3 pe isopropyl, and 4 pe methyl. Same. Both are same. Pink can be the answer, red can be the answer. No, both are same. Both are same. No two answer. So either that or this. Both are same. Both are identical. Both will give you same answer only. So once you write the name, you will see both of them will be same. Okay. So it is going to be 2,6 where there is dimethyl, 3 ethyl, and 5 isopropyl. If you want, I'll write the name also here. So ethyl will be written first, then methyl, then isopropyl. So isopropyl starts with the I, methyl starts with the M, ethyl starts with the E. So E will be written first. So 3 ethyl, 2,5 dimethyl. Okay. Although the naming rules have to be written after some time. At number 5, we have isopropyl. I comes before methyl. So I will be written first. Isopropyl 2,5 dimethyl heptane. Heptane. Yes. Correct. 2,6. Sorry. 2,6. 2,6 dimethyl heptane. Okay, so this is about the first rule. I have just told you rule 1, rule 2, rule 3 I have told, but we will be writing those rules in the next class. If you want, quickly take a screenshot of these molecules and name them. Okay, take screenshot everybody. 4 screenshots you take, 18 names are there. I want you to try them. Tomorrow I will discuss them. Is it good? Yes or no? Is everything clear to everybody till now? Yes or no? Take screenshots now. This is the first screen. Take a screenshot. Take a screenshot, second screen. Try naming them. Third screen, take a screenshot. Third screen. Fourth screen. And fifth one. So these 18 questions are there. I hope you have taken the screenshots. And I took a promise from you in the last class. If you have not seen the last class, please watch it also. One promise I had taken from you. That promise you should fulfill today as well. Okay, see you all in the next class. Bye bye. I hope you have all enjoyed the class. See you all in the next class. If you have enjoyed it, please put a thumbs up first. Okay, and then we will end the class. Bye bye. Thank you. I'll wait for your reply first, then meet you all in the next class tomorrow. Bye bye.